And then, okay, it's already recording. So yeah, as I've mentioned earlier, optimization is one of the application of derivatives, guys. And I hope you were able to watch the video, the 3-minute video I have uploaded on YouTube. It's from Alpha One. If you want to subscribe to his YouTube channel, you can. There's a lot of information you can find there about mathematics. And I believe that video explains like introduction of what is optimization, like the application and where or which discipline it can be applied to. Okay. So I hope na namoy ka ng idea on how to like or what's really the use of solving derivatives when you saw the video. Okay. So before we formally start the discussion, guys, I want to ask you, how is the assignment? Kumusta ang assignment? Um, was it complicated or was it what? Lisod? Which item is lisod? Is it number 1, number 2? Let me just, I'm not going to answer all of the items. I'm just gonna like maybe choose 1, 3, and 5. Okay. Was it lisod or maybe because it was too long for you? Number 3. Okay. Number 3. It's also complicated, sir. Which one? Number 3? Okay, so let me try to answer number 3 for you guys. So let me take a snip of this item. Siki. So, all right. So if you notice here, we have a polynomial function. In other words, we have a combination of um, algebraic term and what? Trigonometric term and the constant. So it's going to be like this, guys. I hope you are able to follow or you're able to solve this successfully. 5 ln x minus 2e to the power of x dx 4x plus cosecant x plus wa ako sa whiteboard? Sure? Wait, one moment. There. I hope I'm already on the... Okay. Plus 4 raised to the power of x plus cosecant x dx, and then the first expression under the first parentheses minus 2e to the power of x. No? So our concern here, guys, are those terms or expressions right after dx. Once you are able to solve them, then you're good to go. Okay? So we are not going to do anything with this one here, so we are just gonna copy that minus 2 to the e 2e to the x, then times the derivative of this one here. What is the derivative of 4 to the x? Diba, is it 4 to the x ln 4? Tama? Okay. Plus the derivative of cosecant x is cotangent x cosecant x. So cotangent x cosecant x. There you go. And then plus 4 to the x plus cosecant x times the derivative of this one here. Guys, if you see a constant gani, guys, you just have to copy that constant. And then you multiply it with the derivative of the next term. And that's going to be 1 over x. Minus, you see a constant with sa 2e to the x. You copy that 2. And then what is the derivative of e to the x? It's just e to the x. And then 5 ln x minus 2 to the ex times 4x ln 4 plus cotangent x cosecant x plus 4x plus cosecant x 5 over x minus 2e to the x. Mana? Question so far. Well, you have the option to you have the option, Josh, to distribute. But remember, I said before, nga, if you are naabot na mo ana, you have the option to either distribute it or not. But when you want to distribute it, just be careful that you are doing it correctly. Okay, like there's no error as far as the signs are concerned. When you multiply numbers, dapat sakto yun siya. That makes it kapoy because you distributed it. Diba I said kani, if you remember, I said nga, since you are not going to take mathematics in your as your field of expertise when you go to college, I'm good with not distributing with these numbers here. Someone is asking dili negative cosecant, cotangent, cosecant. Negative ba guys? I'm not really so sure. I don't memorize it. Kasi kakaibaw ko nga ang derivative sa cosecant is cot x, cosecant x. Yeah, it's negative. So it is negative. I'm gonna change this one to negative. There you go. There. All right. So I think that's it. So I'm gonna erase this illustration, huh? Wait. Okay. It's recording naman ata. Okay, it's recording. Erase. And then we'll start now the actual discussion for today's topic, which is optimization. Before we proceed, how do you observe or how do you describe an increasing function, guys, or a decreasing function? Increasing and decreasing function. So how would you like define it? How would you define it? Okay, unta mabalik na ilang Wi-Fi. So, um, let's say for example, I have a graph like this, and then a graph like this. We can say that this function is increasing, right? Based on what we see on that function. But how would you like make an extensive definition of a function that is increasing? What do you think? How would you define it? Maybe you can say, sir, the function should be going up to the right. That's one example. However, when it comes to mathematics, my good guys, when we define things, it has to be specific. So it has to have a representation. So when you say, sir, a function that is tending or that is going up to the right is increasing, if I'm going to ask you, do you think it's good to all elements of that specific situation? So some people would ask you if it's really true. So what we need to do, guys, is we're going to pick up um, point. So let's say, for example, this is x sub 1, no? Kana siya dira. And then this is x sub 2 here. Kani siya diri. Somewhere here. Kana nga point. It follows nga iyahang kanang y counterpart is f of x sub 1. And then this one as well is f of x sub 2. No? F of x sub 2. So by just looking at the illustration, guys, we can say that this function is increasing if x sub 1 is, sorry, my bad. F sub 1 is less than x sub 2. Does it follow? Okay, now ang values sorry guys, now ang values here. The values of x sub 1 and x sub 2. Which one is bigger? Diba it's x sub 2? Which one is lesser? Diba it's x sub 1? It follows nga, if x sub 1 is lesser than x sub 2, then the function f of x sub 1 should be also lesser than f of x sub 2. Which one is bigger aning duha? So if the scenario is like this, now if the scenario is like this, we can say that the function is increasing. Now okay, tanawa yung process, it's going up to the right one. And this is where we make definition in mathematics. We make like an assumption ba or mga, what we call this, mga examples, specific elements. So a function is said to be increasing if let's say, for example, no, if for some x sub 1 less than x sub 2, then f of x sub 1 is less than f of x sub 2. Does it make sense? Ang definition, guys. Is it too technical for you? No? Well, what I questions the definition? Makes sense, right? Very good. So let's work on doing the decreasing function. So let me draw an illustration first before we make a definition. No? Sorry. So it's going to be something like this. And then, again, for us to be able to define explicitly, we need to choose a specific element. So this is going to be x sub 2 here, and this is x sub 1 here. It follows that the corresponding function value for x sub 1 is also f of x sub 1, and the corresponding function value of x sub 2 is f of x sub 2. Amen? So compare these two things, guys. Which one, again, this is a decreasing function. It goes down to the right. Which one is bigger? X sub 2 or x sub 1 in this case here? X sub 2 or x sub 1? Sure? Sure? Which one is bigger? Is it x sub 1 or x sub 2? Sure. Sure? X sub 1? I'm looking at this one here. This one. These two numbers there. X sub 1 or x sub 2? Which one is bigger? Still bigger sa x sub 2. Okay. That's my question. So x sub 1, x sub 2. So in other words, x sub 1 is still lesser than x sub 2. Then, the function that you have here, it's the other way around. Which one is bigger this time? It's the f of x sub 1. So f of x sub 2 is now less than of f of x sub 1. Do you follow? Nagets na? Nagets na? Nagets na tanawa? If we're going to compare these values here, the value that is on the higher portion compared to the other is the f of x sub 1. It follows that the higher value is f of x sub 1. Does it make sense? Now, to make a definition, we can say a decreasing function is said to be decreasing if for some still the same, x sub 1 less than x sub 2, then it's the other way around. F of x sub 1 is greater than f of x sub 2. Questions so far? So I hope you see the difference, huh? I hope you see the definition or the difference of these two different functions. Okay. Nagets na? Okay, very good. Let's have a quick example. The graph of a function f of x equals x cubed, guys. If we are going to graph it, we have 0, 0. We have 1, 1. We have 2, 8. 8. Somewhere here. We have 3. What is 3 squared? 27. So 27. If we're going to extend it, ayan porma, guys, as in ani. There. That's an anayang forma. So you can see, guys, that's an increasing function. So if we're going to pick a representation of x value here, let's say, for example, I'm going to choose this is our x sub 1 and our x sub 3. Because this is an increasing function, dapat, in-solve na to ani, ang f of x sub 1 and f of x sub 2, dapat ang value ni f of x sub 1 is less than f of x sub 2 because that's an increasing function. So let's try to solve. Our x sub 1, sir, is 2. Our x sub 3, sir, is, sorry, x sub 3. Our x sub 2, sir, is 3. There. So it follows nga itong f of x sub 1 equals 2 is 2 raised to the power of 3, which is what? 8? 8. And then our f of x sub 2 is equal to 3. That's going to be 3 raised to the power of 3, which is equal to 27. So if you notice, the f of x sub 1, this one here, has a value of 8, and the f of x sub 2 has a value of 27. Which one is bigger? Is it f of x sub 1 or f of x sub 2? Or which one is lesser? The value that is lesser is actually f of x sub 1. Because f of x sub 1 is just equal to 8. And f of x sub 2 is equal to 27. So it clearly shows that this function f of x equals x cubed is an example of an increasing function. Okay? Question so far? Question so far? None. Okay, very good. So let's say, for example, let's have another example, guys. F of x equals x squared plus 2x. Now, I haven't shown any illustration of the function, so we can't tell if this is going to be increasing or decreasing. Tama? Unless if you're going to graph it, and graphing the function would take you some time. Let's say, for example, how to do it, man. Junior high school mathematics, guys, is you are going to assign values of x. You remember, mag table of values, and then you solve for the f of x. If you remember these, -3, -2, -1, 0, 1, 2, 3, and so on and so forth. And then you substitute these values into the function here. You solve for the specific output, which is the f of x. And then you do for -2 as well as -1, 0, 1, 2, 3, and so on and so forth. And then after you do everything, you're going to plot the points on the Cartesian plane and then connect the points. And that's when you can tell that the function is increasing or decreasing because you would be able to see asa siya padung if it's going up to the right or going down to the left. I mean, going down to the right. Pero if we are not going to do that, so it's going to take some time, or especially when it comes to doing a test. No? Okay, sir, like for example, you want us to determine if the function is increasing or decreasing, and then we're going to do the graphing method. For one item, so it will take us for like, for example, 5 minutes, sir, and then there are 40 items in the test. What if all the items in the test is or are determining us for like to determine if it's increasing or increasing? Murag kuwang ra gyud ang kuan, sir, ang 5 minutes per item. So, usa man na siya, sir. There is a definition that we can use involving derivatives. So increasing and decreasing function involving derivatives. Sige. The definition says nga, suppose I'm gonna just nawa mo gud ako ang kuan, guys. Nawa mo gud ako ang PDF access book, so I have to write it. But yeah, before we do that, I'll just give you an example. Tell me if this function, if f of x is equal to x squared plus 2x, is increasing or decreasing or neither over the interval -3, -1. Okay. So how to do this? So unsa may buhaton ani, sir, nga you are asking us nga if the function is increasing or decreasing for that specific interval nga -3, -1. As I've mentioned, sir, ang among buhatan ni sir no kay among matamatahon or amo ang buhata graph niya ang mga numbers sa x sir kay -3 to -1. So -3, -2, -1 yung mga decimals sir in between those numbers so that we can see clearly if it's increasing or not. And then as I've mentioned, it will take some time. So what we're going to do here, guys, we're going to make use of the derivative for us to be able to know if the function is increasing. So first thing first is you pick or you solve for the derivative of the function. So what is the derivative of the function? We know it's, sorry. The derivative of the function, guys, is equal to 2x plus 2, right? Agree? Agree? Okay. After that, you pick a representative in between of these numbers. If you notice this, be careful also that the interval is using the parentheses. This means saying no, we are not allowed to use -3 and -1. In other words, they are excluded. The numbers that are supposed to be used are those numbers in between -3 and -1, okay? Unless if the interval uses the bracket symbol. So I hope you took note of that. So what would be the number that we can choose as a representative from that interval? -2. Very good. You can choose decimal. You have the option to choose decimal, but for convenience purposes, para di na malipat, I would suggest to use the whole numbers. Okay? I mean, the integers. So we're going to take a look at what is the value of the derivative function representing or choosing a representation of -2. So we have -2 plus 2. This would give us what? -4. Sorry. That's -4 plus 2. We have -6. Right? Right? Is it -6? Can someone confirm if it's -6? It is -6, right? I think so. It's -6. I know it's -2. Yeah, thank you so much. It's -2. Okay. So in this case, guys, we can tell that over this interval, okay, I'm going to explain it to you. Over this interval, the function is decreasing. That is because the value of the derivative with that specific item that we pick or value that we pick is less than 0. So if we're going to make a definition here, guys, suppose a function is defined, defined over a given interval. The interval that I'm talking about here on the actual given, guys, is the -3 and -1. But since we are making a definition, we're going to be using letters lang to generalize everything. So open interval, let's say, for example, AC. No? I'm using these letters para musakay sa inyong libro. Kaya I know that you guys are accessing the book. AC. Then, the graph, musa may pasabot ani, the graph of the function, kaning example ha, it's -2 man, is decreasing, no? Is decreasing if the first derivative f of x is less than 0 for all cleared. So example, you have, okay, one moment, wala po ako ang kuan. Wait guys. Can you hear me or no? Can you hear me? Okay, yeah. For some reason, naputol ako ang kuan. Anyway, so let's go back to the definition that I'm just one. Wait, ha. Share. Guys, please tell me if you see like kanaganing mga kanamurag black bar. Do you see a black bar on the screen or no? Na ano? Mo kuan siya, mo cover siya sa entire screen ninyo. Nora. Okay. All right. So going back to the definition that I'm just trying to say earlier, guys, is that um suppose you have a function. No, you have a function, and then that function is defined over a given interval. So for this example that we have here, the function that we have is x squared plus 2x. It's defined over the interval -3, -1. The definition gives us AC. I use the letter AC to generalize everything. And then, ang function daw niya is decreasing if ang derivative ana nga function niya kanang x nga gipili na to guys, kaning x guys. And if you notice, kaning x guys is the representative that is actually picked from the given interval. So that's why, for example, it says here nga dapat siya ang yung derivative is less than 0 sa tanang x nga imong i-pick nga naa sa interval nga AC. So kani nga x guys is coming from this interval here. So sa kani nga actong example that you see here, the x that we pick is the -2 which comes from the interval that we have here. Okay? Gets? Naka-follow ra? So if we're going to define the increasing definition, if we're going to define the increasing definition, we're just gonna add here. So point na siya and na siya no and. The graph, same gyapon ako nila isuwat balik. Suppose no, a function is defined over a given interval. Same gyapon ang condition guys, AC, then the graph, sorry, pasensya ko ng agi guys, the graph of the function is increasing this time. But the difference, guys, is the first derivative with the number that you pick should be greater than 0 for all x belongs to that interval. So let's try to see. Let's try to figure out. Okay. So I'm gonna be using the same function, guys, but I'm going to make a twist on the interval para lang musakay ani nga situation here. Kaning second statement or second definition. So we're still gonna be using the same function f of x equals x squared plus 2x. I want you to check if it's increasing or decreasing under the interval. One moment. Under the interval, on the interval, negative, I'm just gonna be using the something on the book na lang. -1, 5. So again, you pick your representative, which is an x value from this interval. Can someone pick, please? Can someone write? Any number. Okay, let's use, would you want to use 0? No, 0. Alala 0 kay ma-0 mas 1. How about 3? 2. You can use 1 or yeah, whatever. So since nag-type man si Eliza and Andrea og 3, I'm gonna be choosing 3 ha. So next, we're gonna take the derivative of the function. The derivative of the function, guys, is 2x plus 2. Amen? And we're gonna be substituting this 3, guys, sa derivative na. So f prime of 3 gives us 2 times 3 plus 2. This is 6 plus 2, and that's equal to 8. Is this greater than 0 or less than 0? It is greater than 0, right? Greater than 0. This follows nga ang kaning nga function, guys, for this given interval, it's increasing. Okay? It's increasing. So without using the graphing way of telling us or determining if the function is increasing or decreasing, we can use the concepts of derivative for us to be able to tell if the function is really increasing, decreasing, or not. Okay? So question so far. Wala? Okay. I'm gonna show you um, the GeoGebra para would really that's a good question, Ogalino. Guys, when we make definitions in mathematics, guys, it has to be explicit. It has to be explicitly defined, specific as much as possible. So if there's no interval, we cannot tell if the function is increasing or decreasing for that given item. So it has to have the interval. Okay? So if I'm going to ask you, is this function increasing or increasing or increasing? Polynomial function ang pasabot ha. We can tell if it's going to be, what was the value? X squared plus 2x. So this is the function that we have, guys. The first one or the first interval that we have was -3 here. -3, this one here. How to add a -3, -1. Work siya. Siya mo work. Okay, ako na lang ikuan ha. Ako na lang i-show ha. I'm just gonna take a screenshot of this. Kani. And then, ato siyang drawing-drawingan sa whiteboard here. Stop sharing. And then, share this one. Okay. So the first interval that we have on this particular, by the way guys, kaning function is mao ni ang graph sa x squared plus 2x. Kani ang gi-show sa inyong whiteboard. Okay? I hope you can see it. Can you see it? Can you see the illustration, guys? Chat. Okay. So kanyang function, guys, is the graph of this x squared plus 2x. The example that we have earlier. So the first interval that we have, guys, if you notice, we have -3, -1. We are going to like focus ourselves sa kanang interval and we are going to try to see if the function is increasing or not for that particular interval. So we have here -3, kani siya nga portion here, -1. So consider na nga part, guys, is unsa may forma sa function within this interval here. If you notice, this is the function form. What does it tell you? Sorry, hiwi ko kaagi. What does it tell you? Dili na ko to sa one. Going down. It's going down for real, in other words. So we can tell that with that specific interval, the function is decreasing. Diba? So without even graphing it, we can tell the function is decreasing with the definition that we have covered earlier. Now, next interval, was it -1, 5? So from here, -1 from here, and then we go here. So the interval that we are looking at, let me change color ha para makita niyo ang difference, is this interval here. We want to try to study what's the function behavior for that specific interval, -1 to 5. In fact, you choose 3 as your representative. So if you're going to take a look at it starting from here, the function behaves like this. So what can you tell? What can you say about the function with that interval? It's going up. It's increasing, right? Good. That's a good answer. Now, guys, kani siya nga part here. This is what we call nipple. No, just kidding. Recordability. This is what we call critical value. Critical value. That's a critical value. Okay, critical value, guys, it's somehow you can say it's a turning point of a polynomial function. There are functions nga lahi og porma, guys, nga nga function. Now, for example, no, these points that I'm showing you guys, kani sila, these are what we call the critical value of the function or turning point. These turning points can also be solved with the use of derivative. No, so that's one way of solving the derivative. Sige. Let me show you a definition first. Katawaan nila sa kuha niya. Let me show you a definition of a um, critical or a critical value. So guys, take a look at here. Unsa may ordered pair ani diri? Negative 1, negative 1. Tama? Negative 1. Tama? Is that correct? Do you agree? And this function is f of x equals x squared minus 2x. That's the graph of that function, right? Is it minus? Minus ba na siya? Minus? I plus the I plus, my bad. It's plus. Okay. So that's a graph of the function x of x squared plus 2x, and that's negative 1, 1. Kaning x, guys, is this is the critical value. Critical value that we are talking about. Kaning ordered pair is what we call the critical point. So I hope you see the difference between critical point and critical value. Critical value is the x value of the critical point. Critical point is a combination of no. Critical point is actually a representation of an ordered pair. Okay. So how to use critical or how to use derivative, guys, to solve for critical value? This is very easy. Solving critical value or values of a function using derivative. Okay? So, any. But first, let me define, or let me give you definitions. Definitions at that. A number, this is actually in the books, guys, so you can you can refer to the book. A number C in the domain. So, kaning number C, guys, kaning number C or kaning value of C is part of the domain. In other words, this can only be taken from the X values. Remember what is a domain? What's the definition of a domain, guys? Hello? How do you define a domain? Or how do you define domain? Values of x for which the function is defined. Very good. So, in other words, kanang value nga C, guys, it's any number that is coming from the domain. My bad. Is undefined. Okay. So here, with this definition that we have, solving the critical values of a function using derivatives. Now, had it or we since for example, wala na tayo graph ang function, I hadn't shown you the graph of the function. And then for this the same function here, can you solve the critical value? Okay? Can you solve for the critical value for that function, sir? It's very easy, guys, with the help of this definition that I showed you. A number C in the domain of a function f is said to be a critical number of the function if either the first derivative using that c should be equal to 0 or the first derivative using that c is undefined. So if I'm going to use the same function f of x equals x squared plus 2x, I'm going to solve first the first derivative. So the first derivative, guys, is f of x equals 2x, sorry, 2x plus 2. Tama? Agree? I believe everyone agrees to this. And then how to find the critical value? Simple. You just have to equate the f of c to 0. So this becomes 0 equals 2x plus 2. And from here on, you're going to solve for the value of x. So how to solve for the value of x? That's going to be 2x minus negative 2. Agree? and dividing both sides by -2, you would have x equals -1. There you go. This is the same thing as what I have shown you here. Do you follow? So in solving the critical values of a function using derivatives, this is what you're going to do, guys. Solve for the derivative first, okay? And then after you solve for the derivative, you equate it to 0. After doing such, you solve for x. Okay? So let's have an example. F of x equals x over x squared plus 4. How about that? How do you think we're going to answer this? So we're going to solve for the derivative first. And since this is a quotient function, we're going to be using the quotient rule. Okay? So the first derivative is f of x equals x squared plus 4 times derivative of the numerator, which is equal to 1, minus um, x times the derivative of the denominator, which is 2x plus 0, or 2x na lang, over x squared plus 4 equals 0. I'm sorry, equals 0, squared. And then after getting the derivative, we're going to be equating it to 0. So this becomes 0 here. So that's going to become x squared plus 4 minus x. I'm just going to write 2x squared over x squared plus 4 squared. Do you still follow? Do you still follow the solution? Okay. Next, I'm going to combine the numbers or terms on the numerator. We have 4 minus x squared over x squared plus 4 squared. And then we do cross multiplication because we're solving for x here. Cross multiply and then cross multiply there. We have 4 minus x squared equals 0. Okay, when you multiply 0 to this term in the denominator, ma 0 magyapon na siya. So that's still going to be the same 0. Solving this time, we have 4 equals positive x squared, transferring negative x squared to the other side. Getting the square root of these two sides of the equation, we would get x equals plus minus 2. So the critical value, guys, the critical value is x equals plus minus 2. But what na human? Nga naman, look at the definition here, guys. It says nga either kani siya ang first derivative ma equal to 0 or ang first derivative is undefined. Kano sa mahitabo ang function ma-undefined? Can someone tell me? Kano sa siya mahitabo? Ma-0 ang denominator. And if you notice, the denominator of this derivative here is kani. Di ba morning denominator? Di ba morning denominator? You said nga ma-0 ni, so we still need to work this out, equating that to 0. So aside from this cross multiplication, additional work need to be done is kana 0 equals 0, which is the denominator. So getting the square root of both sides, we would get x squared plus 4 equals 0 still. Okay? And then this becomes x squared equals -4. Tama? Solving it like this, like that, the answer is imaginary number. Amen? In which we are not going to be including in the solution because, again, remember, the function or the domain should be a defined term, a defined value of x. We don't consider those imaginary numbers, which are not part of the real numbers. So technically, the answer is kanina siya, guys. However, if your denominator would not result to an imaginary number, that would still be part of your critical value. So let me give you an actual example. What if the denominator is x squared minus 4? So let's try to change it to x squared minus 4. I'm just gonna change it to x squared minus, let's say 9. For example, kana imong denominator, no? If we're going to solve this, guys, mahimuning minus 9 here, mahimuning positive 9 here. Tama? Getting the square root, the answer will not be imaginary. You would get plus minus 3. This answer, guys, is still part of your critical values. So in other words, for this example, you have 4 critical values if you are going to change the denominator to x squared minus 9. If the denominator is not like this, or if we're going to go back to the original denominator, which is x squared plus 4, then our critical values are only positive 2 and negative 2. Question so far? Okay. Masabtan na so far? Okay. Um, Guys, this is just a quick overview of what is maximum and minimum, okay? This is the function there. When we say minimum, guys, there are two different types of minimums. We have the maximum, we have the global minimum, we have the relative minimum. The global minimum, guys, is the lowest point of the function, global. Um, I'm not sure if the book uses global, but let me see. Yeah, I don't absolute. The book uses the word absolute minimum, so it's the same thing when you say global and absolute minimum. Absolute minimum, guys, is the lowest point of the function. Okay. The relative minimum, guys, are the low points, but not lower than the lowest point. Okay. The absolute maximum is the highest point of the function. We also have a relative maximum. These are um, high points of the function, but not higher than the highest. So here is a scenario. This point here, these numbers, guys, this point here is what we call the minimum. Okay? These are the minimum point. But this one here, this specific point here, is what we call the absolute minimum. Because that's the lowest minimum of the function. These three is what we call the relative minimum. Okay? Now, this point as well, this one here, these are what we call the maximum point. However, this specific point here is what we call the absolute maximum. Okay? Because that's the highest point. But these two here, guys, though they are high points but not higher than the highest, we call them the relative maximum. Okay? So just an overview of the names of the graph, guys. So let's work on an actual example na, guys. No? Ready for an actual example na? Sige. Ay, kana akong gamiton. Okay. A delivery company. You might be able to see this item on the book, guys, but I will just explain it to you. Yun sa siya pag-answer. To come up with a package box that has a square base and volume of 40 feet cubed. What should be ups the dimension of the box with the least amount of material to be used. Okay, so that's the problem, guys, no? So we are doing optimization here. We're looking at minimizing. So if you wish to create the box, guys, of course, if you were to be like someone in the business or someone who like doing cost effective creation of the box, you should be looking for like least expensive. At the same time, the material will be like as much as possible ma-maximize ang material nga imong magamit with the least amount that you're going to spend. So this is an actual example of a function, I mean, a problem that talks about optimization. Okay. First step that you're going to consider, guys, is to understand the problem. Now, let me ask you, do you understand the problem? Okay, very good. So I believe that you understand the problem. Next is you need to create a model. Okay, remember, if you notice our examples, guys, we have to have a function where we can solve for something, where we can solve for the critical value, where we can solve for we need to know if it's increasing or decreasing. So in other words, we need to have a function model that we can work on. And this is one of the challenging part, guys, because for those students or for those people who are not very um well learned when it comes to mathematics, they're going to be having issues on how to create the model. But the clue, guys, is in the problem, Rajud. Sige. I'm gonna draw a box, no? Draw a box. Kana. There, that's a box. Now, I'm gonna label each side of the box. This is X here, and this is X here, and this is Y here. The question here, sir, why did you label the dimensions of the bottom part of the box? Who can answer? Hey, why did I label the bottom part of the box as X? Why did I assume that they are equal? Who can answer? Okay, it's in the problem. It says the base is a square. It says here the square base. I'm sorry, it's a square base. In other words, the base should be in the form of a square. The sides of a square are equal. So that's why I label each side of the base alone nga x and x. Agree? Now, the question is, why did I label the height of the box as y? Why not x? That's my next question. Why did I label the height of the box as y? Why not x? Well, because vertical, sir. Okay, that's a good answer. Because longer siya. Sure. Very good. The answer is we don't know. We don't know. It didn't actually give us a clue in the problem. Did it tell us nga unsay height or did it tell us a property for the height? Wala. So we can use any letter. So ayaw libog-libog ang inyong self, guys. Don't overthink things. So, okay na tano. Karon. Okay na tano. So, um, what do you think is the model that I'm going to use, guys, that would make sense in the problem? When I say model, guys, I'm looking for a specific function formula. You can say formula or function model. What do you think? Who can answer? Okay, that's a good answer, Adriel. F of x equals x squared. Um, what's the when it comes to like shapes in your geometry, guys? What do you think is x squared? Where did you get that formula from? If you think about your geometry in your junior high school before, that's side times side, which is what? What is that? Side times area. Very good. That's an area of a square. However, we are not looking at the area of this particular problem. We're looking at the volume. That's the point, Gwyneth. That's what I'm trying to look for. So instead of using area, we should be using volume. Amen? And what's the area of the volume of a box? Base times height times length. Tama? So volume formula, sir. So volume is base times height times, I'm just gonna write base times height times length. So volume, guys, the base is x, the height is also x, the length is equal, sorry, the height is y, the length is x still. And that would give us v equals x squared times y. Amen? Very good. Nakasinabot na? Okay. Okay. Now, we know what's the volume. Pila may volume? Pila yung volume? 40. So I'm going to change V to 40 equals x squared y. Very good. Now, guys, when we say the word dimension, what do we mean by dimension? What do we mean by dimension? Measurement? Measurement of what? Very good. It's actually the sides of the shape that you are looking for. You are trying to focus on the side of the shape. Agree? That's a dimension. For example, I have I have this I have this flat. Do you see this? I have this. Do you see this? You don't see it. I have something flat for kana kaning wall ninyo, guys, kanang wall bas yung bongbong bas yung balay sa imong kwarto. Kanang, di ba, most of your wall is square man. Ang dimension na is mo nang length sa side. Mo nang dimension. Karon, the model that we are going to be using, since we are asked for the dimension, we're going to be using the volume, not the volume, but the the length, or how to solve for the length of this y here and the length of the x here. What do you think? Saan ka na siya? So what do you think, guys? If you wish to create the box, medyo libog ni siya, guys, but I hope you can get this. If you're going to create the box, how many wall, or how many, let's say for example, plywoods you are going to use? 6. Great. So that's gonna be, you're looking at the surface area. Tama? Surface area. And ang each box ba? So I'm gonna write 2 x squared plus 4xy. Nakuha ninyo nga nung nanang forma? Nag-gets ang ano? Okay. I'm gonna do it like each element ha. Ang kaning x squared, guys, is the area of the base. Agree? It's the area of the base. So usa ka plywood na siya. Nganong duhaman because you still have the area sa babaw. Very good, top and bottom. So that's why you have two. Very good. Kaning xy, guys, is the area sa each side sa box. Nganong 4 man, upat man nakabukside para makompleto ang box. Does it make sense? Very good. Great. Good. Now, the problem here, guys, arita mag-solve sa tuang derivative. Mo na itong pangitaag derivative. Pero, the problem ang good is natin usa ka value o natin usa ka term nga y, and then, based sa previous examples, our values or our variable nga naa sa right side should only be 1. X ra gud siya. Nawa, kaning example kay x ra ang naa sa right side. X ra naa sa... Previously, yung mga examples sa before, di ba, x ra ang naa sa right side. So, unsaon man ni siya, sir? We're gonna be using the details nga naa sa tuang atubangan to make use para ma-convert ni into x na lang yun. This is how you're going to do this. This is equal to, this is the same thing as y equals 40 over x squared. Do you follow what happened here? Do you follow what did I do here? Kaninga part here? Nagets ra. So with that being said, this y here can be used to replace that y there. To make sure nga natay x squared, puro lang x atong SA. So SA na to, guys, surface area is 2x squared plus 4x times 40 over x squared. Hello? And then I'm going to simplify this. SA equals 2x squared. What is 4 times 40? What a question ni Kuan ni Lenny Robredo. Charot. 160? No? Over x. Okay. So guys, mo na itong pangitaag derivative na. Nganong kanima na itong pangitaag derivative, sir? Nganong dili man ang volume? Because it tells here man nga, unsa may dimension sa box nga naay or with the least amount of material. In other words, unsa may size sa each side sa box. And that would give us the surface area lang, dili ang volume. If the question is, unsa may amount nga ma-occupy sa box with the least amount of volume, with the least amount of liquid, mao na to ang volume may gamiton. Kay imo mang sudan ang box. But your question here is the dimension of the box man. Amen? Amen. So first, let's try to look at the derivative. So I'm just gonna SA prime lang, SA prime equals. So sa may derivative ani? Kaning 2x squared. 4x. Kung sa derivative aning 160 over x. Nope. 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 I-solve kahan ninyo dira ang inyong quotient rule. Sige, kamo na confirm sa quotient rule ha, but the answer is negative 160 over x squared. Kamo na solve sa inyong quotient rule dira. It's negative. Kasano to? Eliza, it's negative 160 over x squared. 160 over x squared. No? Next is, we're gonna solve the critical value. So, saan kita mag-solve sa critical value? We're gonna change this one into 0 and solve for the function 160 over x squared. Okay. So, guys, I'm gonna combine these two, ha? I hope you still know how to combine this. So, that's gonna be x squared 4x cubed minus 160. Huh? And then I'll cross multiply. I'll cross algebra gyapon ni guys. I'll cross multiply, so I would have 0 equals 4x cubed minus 160. Tama? And then I'm gonna transfer 160 equals 4x cubed, which would give us what? Um, x cubed 40. Tama? Divided by 4 both sides. And then getting the cube root, x cube root of 40. Pila na guys? 70? Approximately 70? Sakto? 70? Sakto ba? Confirm daw. Where's my calculator? Ha? Sure, oy. Ay, sayo ko. 160 divided by... X equals cube root of 40. 3.42. Yes, 3.42. There you go. This is now your critical value. And that's the length of your X. Diba? Diba? Na kay X. Diba? Dimension ng gipangita? Agree? Na kay X. And how to solve for Y? Ang sa pag-solve sa Y? Unsa na siya nga question o galing na? Is it ang Y ilisan or ang X ilisan? Kari diri. Using this, the Y equals 40 over 3.42 squared. Right? And that's equal to approximately 3.42 still. Tama? Yes. So the answer to this question, guys, what should be the dimension of the box with the least amount of material to be used? The dimension is the length or the base should be 3.42, the height should be 3.42, and the length should also be 3.42. Question so far. Right. Guys, I'm gonna show you guys yun sa po na kanang mga, if you're going to check the book guys, kanang mga interval dira ba. So we have this surface area no equals unsa man to surface area nga formula na to. Kani surface area nga formula is 2x squared. Ako lang buhatag table ha para makita ninyo pa. So diri ang interval. And then diri wait siya. Yes, depending sa question. SA equals 2x squared plus 160 over x. And then, ang first derivative is SA. Is it the first derivative? Ano? Ito sa obos. Kanino? Kana. 4x minus 160 x squared. Kani siya kay conclusion. I'm gonna show you ha yun sa kanang illustration sa libro mga table pa para di mo malipat nga nung naabot ko diri-diritso. Sige. How to determine the interval, guys? Ang interval, guys, is may determine na siya using the critical value. Your critical value is kani. Tama? Kanang 3.42. So, imong buhaton is mag-start to og 0 to 3.42. Why did I start with 0? Why not negative? What do you think? We still have 7 minutes. I need answer. Why did I start with 0? Why not with negative? Because definition, Which definition man? Very good. There's no such thing as negative length. So that's why I started with 0. And then, and next to it, guys, is ang kato ng x nga critical value nga 3.42. And then next sa interval is 3.42 until infinity na. Magkadako na ang length. So, guys, ang imo nang solve na ni nga part, guys, kani siya nga part here, kanang function is when x is equal to 3.42. Ay na siya i-solve using this interval. So, unsa may value ana? I'm just gonna solve it 70. Kung imo nang kanaganing 3.42, guys, you substitute the x here, 3.42, you would get approximately 70. Karon, kani diri nga part, guys, kani sa derivative ha, ang imong goal, guys, is you pick a representative sa between aning nga statement or between aning interval here. Let's say for example 1. Masud man ng 1 diri, di ba? Ibutang ng 1 as your x here and 1 here. Ang imong resulta kay negative ra. Ang imo ra i-take note, guys, is ang sign ra. Negative. Kuha? Sunod kani siya, guys, 0 ni siya. Ma-0 na siya dira. Kay inig sabi siya mo ng 3.42 here, di ba? Remember nga mao na ang 3.42 is the value of x when the derivative is 0. So there's 0 ni siyang mahitabo here. Sunod, kanina sa interval, you pick a representative nga ibutang ni mo diri. So you can say 4. And solve ni mo 4 ana, guys, ang resulta nga value is positive. Yang conclusion ani, balik ko na ko sa atong discussion kaniya ha. Ang conclusion ani, di ba if the derivative is less than 0, di ba negative siya? Agree? Do you agree? If the derivative is less than 0, di ba negative siya? Derivative money here nga part. And unsa gani behavior sa function if ang derivative is less than 0? Decreasing. So ang conclusion ni here, guys, decreasing. Gets? Kani diri nga part here. Increasing or decreasing? Kaning third part. The derivative is greater than 0. It's positive. So in other words, it's increasing. Agree? Now, ang question man good, guys, is sa problem, it says nga unsa may gamiton nga dimension sa box nga you would have the least amount of material to be used. Kung imo na siyang sabton in layman's term, atong bisayaon, unsa may gamiton nga dimension sa box nga dili manubra, increasing, nga dili sad magkuwang, decreasing. Nagets? And that's why the answer is kaning a portion here. And that's why our x is equal to 3.42. Nagets ang idea? So sa my interpretation here, it has a relative minimum. Question so far. So dito mo gamit sa decreasing, dito mo gamit sa increasing kay. Okay, good question. Nga nung relative siya, sir? It's because wala man tayo interval nga gi-focus. It's continuous man siya. So kay bawta nga napay mas taas pag ngadto. Nagets? Di ba niya na ako ganiha nga, when we say absolute and relative, absolute is either the highest point of the function or the lowest point of the function. The highest point is the absolute maximum. The lowest point is the absolute minimum. The relative minimum, relative maximum are the low points of the function but not lower than the lowest. The relative maximum are the high points of the function but not higher than the highest. So, if you notice, gitawag tag relative minimum because we know nga decreasing pa siya and increasing siya sa both interval, outside interval. We know nga padung pa na siya nga tong. We don't know asa siya kutob. Nagets? Nagets na? Yes. Question so far. It's already 8:58. So I would not give you an assignment, guys, because I want you to work on your performance task. Oh, di ba? There are two items as a performance task, guys. And some people were asking, sir, about the sketching, sir, ba, do we have to graph it? Yes, you have to make your own graph. You don't really have, guys, what I'm trying to look for is really not doing like assigning values of X. You can just actually do like this and then graph like that and then explain to me where can I find the limit, something like that. You don't have to assign values of X. You don't have to assign whatever, but you can just actually show me like that and then tell me or explain asa magpadong si X. I mean, asa ma-approach as X approaches to a specific value. Question so far. And guys, I'm gonna upload a video later on, additional details on how to like construct tables, huh? Okay, I don't think it's going to be enough for us to cover 1 hour and 30 minutes. But this is the first example that would give us that would help us realize the application of optimization. Right now, I have a lot of examples, guys, that is now that is going to be like medical related. Para at least makarelate mo ba? Yes, I'll upload this sa Shallow, guys. Question so far? Wala na? I'm just gonna. Wala na. It's already 9 na, guys. Ugma, what's Ugma? Tomorrow is Wednesday. Guys, the holiday is only for Cebu City. I'm not sure if Mukuyog ang Mandawi and Lapu-Lapu City. All right. Thank you so much, guys. I'm gonna stop recording.